So good morning students, and we are doing that phytochemistry practical. In this aspect we are going to discuss extraction of Hesperidin from orange peel. That is a practical that we are going to do. So we are going to take orange peel which is dried in nature, and from that we are going to extract Hesperidin molecule. So before going to that thing, I would like to explain the structure of Hesperidin. So Hesperidin is a flavonoid glycoside. You can see here that it is a flavonoid glycoside. So this part is called as flavonoid, and this is called as glycosidic linkage. You know that this is a glycosidic linkage and this is a disaccharide molecule. And this disaccharide molecule is called as retinose, and this flavonoid molecule is called as Hesperidin. And you can look at here, it has a chiral center, and you are going to isolate this molecule as enantiomer pure form. So generally it will be obtained as a racemic form, so this part, but this part is going to be obtained as a chiral molecule, pure chiral molecule, right? So this is about the structure of this molecule. So this molecule contains a flavonoid part as well as a glycoside, that is a disaccharide part also. Clear? Now, what are the compounds, what are the species that contain this Hesperidin? So Hesperidin contains generally citrus fruit and green vegetables. These things will have Hesperidin molecule, but the Hesperidin will be enriched in the case of white part of the citrus peel. You can look at that orange peel will have the white part, right? So the white part will be enriching this Hesperidin molecule, right? So general physical properties of this Hesperidin molecule is, that is a molecular formula is C28H34 and O15. The molecular weight of the molecule is 610 gram per ml, and the melting point of the compound is 262. General nature of this molecule will be a solid. It will be like pale yellow or pale brown solid, right? So which has a melting point of 262 degrees Celsius. Clear? So what are the biological properties of these Hesperidin molecules? So it is generally used as antioxidant, and it also have anti-inflammatory property and antihistaminic property, and it also have antiviral property. The important thing is it has some beneficial effects on blood vessels also. So these are the general properties of the Hesperidin molecule. So this is about the theoretical part, and Dr. Gavaskar sir is going to explain the practical part. Clear? Thank you.
So thank you, Muthukumar sir. So sir already gave the introduction on the aspect of that chemical and the biological property. So how we can extract this Hesperidin from orange peel? What is the procedure? So I can add one more importance of this Hesperidin. So in the year 2019, we got corona, right? So what we used that Kabasara Kudinir in order to save from COVID-19. So similar to that, the Indonesian people, they use this Hesperidin. They use this Hesperidin extract to save from COVID-19. So the lot of research is going on regarding this Hesperidin and in Indonesia, and they are saying that this Hesperidin, it have COVID-19 antagonist property also. We can use this as a anti-COVID medicine also. Okay, so that much importance. So how we can extract this compound from orange peel? First you have to take 10 gram of dried orange peel in a round bottom flask. Add 100 ml of hexane. Okay, so you take this in a Soxlet apparatus. You know what is the procedure or how we can do this Soxlet, you know already. So take 100 ml of hexane, take 10 gram of that orange peel, start reflux for 1 hour. So it can remove all the non-polar oil which is present in the orange peel. So you can extract all the non-polar compounds and oil which already present in the orange peel, and you can observe some colored compound in the hexane layer. Okay, so you can remove the color layer, you can remove the oil, you can remove the all non-polar compounds. Okay, once again you just take that orange peel, which already taken in the oxalate, that thimble, no. Once again, you just take and dry it and chop the orange peel in a smaller pieces. Convert like a powder. Okay, dry it. Once again, you take that 100 gram of chopped, dried that orange peel in a thimble. Now you have to take the 100 ml of alcoholic solvent. You may use methanol, ethanol, or isopropyl alcohol. Whatever solvent available, you just take, no problem. 100 ml of alcoholic solvent and do the reflex for 3 hours. Previously it was 1 hour, now it was 3 hours. Okay. So you will get the compound in the solution, alcoholic solution. Evaporate. Evaporate the alcohol. Try to get the residue. In that one, you have to add 6 ml of 30% acetic acid. Dilute acetic acid, the Hesperidin it will precipitate. Dry it, take the weight and calculate the theoretical weight. Okay. So if you take the orange peel which contain 27% of this compound Hesperidin. Okay. So this is the procedure we are going to do now. So in order to extract the Hesperidin from orange peel, so this is a setup actually. So here I taken 20 gram of orange peel which I kept in that oxalate distillation unit, and here I taken the hexane, 200 ml of hexane. So here I taken 20 gram of orange, and here I am taking 200 ml of hexane. So this is the entire setup for the oxalate extraction, and I am going to start the distillation process. So we need to do our reflex for 1 hour. Okay. So in this process, the oil and the non-polar compound which is present in the orange peel, it will come out. So that's why we are using the non-polar solvent hexane. So this is the first step. So after 1 hour, we will continue the experiment. So after 1 hour distillation of hexane, now we got this hexane extract, and we will keep this separately. Okay. So afterwards we will recover the hexane solvent. So now what we did, once again we taken that orange peel. Before that we dried that one. Okay. So once again we take that orange peel. So instead of hexane, we are taking the 2-propyl alcohol, isopropyl alcohol, and you have to do this distillation for 3 hours. So in this process only we will extract the Hesperidin from the orange peel. Okay. So take 200 ml of methanol and that dried orange peel and do the distillation for 3 hours. So after 3 hours reflex by using the methanol solvent, so we kept for the distillation. So we need to concentrate the solution, we need to concentrate the methanol solution. So further we will keep in distillation. So you have to remove the maximum amount of methanol solvent. After that you have to prepare the 30% acetic acid solution. You have to add, definitely we will see the precipitate of the Hesperidin. Finally, you have to recrystallize by using the acetic acid to get the pure Hesperidin compound. We will see. Okay. Any doubt? Any queries? So after the evaporation of the methanol extract, so we got some amount of Hesperidin. So we are not using entire methanol extract. Some amount we taken and we concentrated, and we got the crude Hesperidin. So you have to add the acetic acid, because in acetic condition only the solid will be precipitated. So you have to concentrate, as well as you have to add 30% of glacial acetic acid. You will get the crude Hesperidin sample. So you have to, in order to get the pure substance, you have to recrystallize this crude sample by using the glacial acetic acid. Any doubt? Any queries? Any doubt? I hope it's clear. Okay. So concentrate, add 30 percentage, 6 ml of 30% acetic acid. You will get the crude hesperidin substance. You recrystallize by using the acetic acid to get the crystal of hesperidin. Then dry it, take the weight, note down in the observation notebook.